All right, let's go ahead and get started, class. Good morning, everybody. Today, let's see here. Somebody's texting me. Let's see what they want to. Okay, so today we'll finish chapter on logarithmic exponential functions. So we're going to learn how to solve both types of equations, logs equations and exponential equations. And with the lecture today, you should be able to do the assignment for this week of April the 12th. Next Monday, I will start the counting principles. Teacher, be sure you have a calculator ready for next Monday. And a week from today, you'll be taking the last exam before the final. We have one more exam and a final. So the 21st of April, you'll be taking that. So next Wednesday, you'll be working on that exam. Okay? All right. So how do we solve? Let's talk about solving equations first. Okay, I'm going to show you some rules that are a little different than your book, makes it easy for you. First of all, what do you mean by a log, for example, a base 2? It means 2 should be raised to what power to give me 8, right? And the answer is 3. Why? Because 2 to the power 3 gives me 8. So if you're asked to solve easy equation like solve log x base 2 equals 5, you just use the definition of log, which is what? 2 to the power 5 equals x. And of course, if you multiply 2 by itself 5 times, you're going to get 32. So these are easy equations. Okay? Or let's say I want to solve ln x equals 3. You don't see the base here, but you know the natural log has a base e. We talked about that last month. So you use the definition of log, which says what? E to the power 3 equals x. And that will solve it for you. Okay? So what if I have log x equals 4? How do you solve this easy equation? You don't see a base. If you don't see the base for log, means the base is 10. So you need to stick that base there, which means 10 to the power 4 equals x. And of course, 10 to the power 4 is 10. So what does that tell you? If you have a simple log equation, like log x base 2 equals 5, just use the definition of logs, and that way you'll be able to solve the problem. Okay? However, what if you have it in a different form? So go ahead and copy this here, class, before I just show you. I will put down the rules for you for logs before I show you equation. Go ahead and copy this and then this here before I show you how to do more. Okay, so what I want you to do now is write down the rules. So I'm going to give you the rules, and then we're going to show you how to solve logarithmic equations. Here are the rules. Rules, these are not on your book, class. These are going to make things easy for you. For solving log equations. Rule number 1. If log x base a equals number r, then it's easy, make a to the power r equals x. Rule number 2, if log a equals log b, just erase the log and make a equals b. So these rules are going to help you a lot into solving log equation. In other words, if you get an equation in this form, use this rule. If it's in this form, then use the other rule. So now we're going to go ahead. I'm going to show you some examples, and then we're going to decide which rule to use. Okay? So here's an example similar to your homework. Okay, solve. And after I show you this, I'm going to pause for a second. Be sure you guys have no question. That's similar to your homework. Log base 6 of 3x minus 6 equals 3. So the question is, I'm solving for x. So which rule can I use, rule 1 or rule 2? So this one looks like rule 1 because I have log on the left and a number on the right. So use rule 1. What does rule tell me? 6 to the power 3 equals 3x minus 6. Then you go to the calculator and you find 6 to the power 3. So I'll go to my calculator here, and I raise 6 to the power 3, 6, x to the power y 3, and I got 216. So how do I get x by itself? I just add 6 to both sides. 216 plus 6 gives me 222. Now to get x by itself, I divide by 3. And when I divide 222 by 3, I get exactly 74. And that will be the answer. So why did I use rule 1? Because I have log on the left and a number on the right. So rule 1 tells you take the base, raise it to the number after the equal, and make it equal to this number. And that way you get rid of the log. Okay? All right, go ahead and copy it and let me know if you have any question. Okay, how's everybody doing so far?
Good.
Record here. Let's see. All right. I'm gonna keep the rules because till I finish all the examples on logs equations. Okay. So that way you guys can tell me which rule to use. But I'm gonna show you one example at a time, and then you guys just get to copy it. Okay. All right. Can I erase just this example and leave the rules, or you guys need
Yes.
more time? All right. So let's start another one here. And all right, I'm gonna remember I need your feedback here, so be sure you guys are participating here. How do I solve this type of problem here? ln, which is the same thing as log, but base e, right? 9x plus 7 equals ln 6x plus 5. So which rule do you think I can use? Rule 1 or rule 2? Who can answer that?
Rule 2.
Exactly. So you throw away the logs. See? Now you just have a simple equation. How do you solve it? Whenever you have variables on both sides, you get rid of the variable on the right side. X minus 6x is 3x. Right? Now to get the x by itself, I gotta subtract 7 from both sides. 5 minus 7 gives me negative 2. I'm gonna divide by 3, I get my answer. Negative 2 over 3. Okay? So I'm gonna take you slowly, step by step, till you learn how to solve all types of logs equations. So go ahead and copy it. And as you're copying it, if you need help, if you want me to go over any part, just let me know. So how we're doing so far, class? Good?
Yes.
All right, can I erase the example?
Yes.
Let's start another one. Now we're gonna make it a little bit harder. Solve ln 9x plus 2 minus ln x equals ln 10. All right. You notice I don't have, I'm going to use rule 2. It says log A equals log B or ln A equals ln B. But here I have two ln's. I need to make them ln one term so that way I can make ln A equals ln B. So what I do in this case is I take advantage of the properties of logs that we learned on Monday, which is what? I make a single log here. If it's subtraction, I divide. So that's why you learn those properties. Now that I made ln something equal ln something, now I garbage the ln. See? I could not do that earlier because I have two ln's on one side and one on the other side. I gotta make it single. If this was plus, then I multiply them. Remember, we work in the reverse rule of the properties of logs. Now, how do I have an equation like this? I'm gonna put 10 over 1. I'm gonna cross multiply. 1 times 9x plus 2, 9x plus 2. Oh, let's cross multiply that way. Okay, we cross multiply this way equal this way. 10 times x, 10x. 1 times 9x plus 2, 9x plus 2. So you see, when I cross multiply, I no longer have fraction. Now I got to take care of the variable on the right side. Right? Answer is x equals 2. So this one I have to do a little work to make the problem I have be part of the rules. The rule says only one log on the left, one log on the right, but I got 2 on the left. To make it simple log, I take advantage of the properties of logs. Okay? All right, go ahead and copy it. And if you have any questions, please let me know.
His last example was first rule or second?
Second rule.
Second.
But I have to make it look like the second rule because why? Second rule says log A equals log B. Here I have 2 logs equals log. So I have to make it only log one term here. So since it's subtraction, I make it division so that way I can make it one single log. Okay, can I erase that example? Or you guys need more time to copy it?
You can erase.
Okay, all right. Let's do a few more. Okay, so let's say I have log base 5 of y minus 7 plus log 6 base 5 equals log base 5 of y plus 3. Okay. Don't copy it, class. I'll give you a chance to copy it after I finish. This is what. So do you agree? I have log on both sides, so I got to use log 2, but I have 2 logs here. I got to make it a single log. Correct? Make sense? So if I have addition, what I do, I got to multiply. So this is going to be log base 5 of y minus 10 times 6. See that, class? Because I cannot use row 2 unless I have only one log on the left and one log on the right. This is addition, therefore I multiply them. If it was subtraction, I divide them. Remember the rules from Monday's class, right? So are we good so far? Are we good?
Yes.
Yes.
Now you garbage the log. I'm going to put the 6 in the front. Is that okay? I'm going to put it so I can distribute here. Now it's easy. Once I get rid of the log, the rest is basic algebra. You guys learned it in whatever, 6th grade, 7th grade. 6 times y is 6y. I distribute 6 times 7 is 42. So how do I solve the equation if I have variables on both sides of the variable on the right side? So I'll have 5y minus 42 equals 3. I add 42 to both sides. 5y is 45. When I divide both sides by 5, I get my answer 9. Okay? So now you can go ahead and copy this as well because you're going to have one like this on your homework. So all of these examples I'm showing you, I took pictures of them from your homework, but of course your problems will change the numbers around. So go ahead and copy it and let me know if you need any help. I need to show you one more, and then you guys should be ready to solve any log equation. Okay? All right, let me know when you're done copying so I can erase the board and show you. Okay, can I erase it now? I'm going to keep the rules just when I erase this part. Can I erase it, Clive?
Yes.
All right, let's try a final on log equations, then we'll go to exponential equations, okay? I always like, remember, these rules are not in your book. That's why you guys come to class, because I show you things that are completely different than your book, something to make your job a lot easier, okay? So let's do something a little different on solving log equations. So let's say I ask you to solve log x minus log x plus 4 equals -1. You know I have to make a single log over here, right? I cannot have two logs. Does that make sense? But I have subtraction, therefore I divide. Right? Correct? Are we good? Are we good, class?
Yes.
Yes.
Now, which rule do you think I'm going to use now? Rule 1 or rule 2? I don't have log on the right side, do I? So I have to use rule 1. But I don't see the base in this problem. If there is no base, who can tell me what the base will be when it's not there?
1.
Base is 10, remember? Because base 10 is a very popular. We don't need to write it for you. Now I use the definition. It says me 10 to the power -1 equals x over x plus 4. But you guys need to know in algebra that any number raised to a negative power is 1 over the number raised to a positive power. Now what happens when I have a fraction equals a fraction? So I cross multiply. 10 times x is 10x. 1 times x plus 4 is x plus 4. You're almost done. Goodbye, x. 10x minus 1x is 9x is 4. Divide by 9. And my answer is 4/9. Okay? You can copy it and let me know if any question. And with this one now, you can solve any problem regarding logarithmic equations. Now we're going to move to the exponential equations, and I'll give you the rules when everybody finishes. So do me a favor now, copy everything, because I want to start exponential equations now, not log equations. I'm done explaining log equations. So I'm going to need the whole board. So let me know when you finish copying all of it so we can start teaching you exponential equations, so that way we can finish the chapter. Okay, can I erase the whole board now?
Yes.
Okay, all right. Now we're going to give you the rules for exponential equations. All right, here are the rules for exponential equations. Rules for solving exponential equations. Rule number 1. If a to the power x equals a to the power y, then make x equals y. If ax is cannot be equals to a to the power y, then place ln in front of each. All right, I'll show you what that means in a minute, class. Okay, so rules for solving exponential equations. If I can get the exponential equation in the form a to the x equals to a to the y, remove the a's and make x equals y. But if I cannot make a to the x equals a to the y, then place ln in front of each term. Okay? So this is what I'm talking about here. So 2 to the power x 5 equals 64. Okay. First thing you do is you don't need to worry about the 2. I need to work on making the 64 2. So you go to your calculator, says, how many times do I need to multiply 2 to reach 64? For example, 2 times 2, 4, 8, 16, 32, 64, 6 times. So if you want to be sure you get the answer right, you go to the calculator. Is 2 to the power 6, 64? So I go to my calculator just to check it. Maybe I made a mistake. 2 x to the power y 6 equals, yep, I did get 64. So what's the beauty of that? Now I can use rule 1. Rule 1 tells you if these are the same, I make the powers equals to each other. And now I just solve for x and I'm done. Okay? So let's say I have another problem here. 5 to the 2x minus 7 equals 625. So I'll leave it 5 to the 2x minus 7. Now I want to see if I can make 625 5 to a power. I go to the calculator, says, how many times do I need to multiply by itself to reach 625? 5 times 5 times. 4 times. Well, let me see. Let's see if 5 to the power 4 gives me 625. 5 x to the power of y, 4 equals, yep. Now that these numbers are the same, I make the exponents equals to each other. And of course, I just add 7 to both sides. 5x is 11. And x will be 11 over 5. Sorry, 2x is 11. Where did I get the 5x? 2x is 11. X will be 11 over 2. And that will be my answer. Let me move the camera here so you guys can see all of it. Okay? So go ahead and copy this class and let me know if you have any questions. I still need to show you more of the same type here. Okay?
In last example, where 5 disappeared.
You remove the 5s. Look at the rule here. If a to the x equals a to the y, you remove the a, you just make the powers equals to, you make x equals 5. So the 5s go away, you just do x minus 7 equals 4. You only do that if these numbers are the same, like the 2 here. These numbers are the same. I don't mess with the 2s. They go away. I just put the powers equals to each other. Do you understand now? You got it? Because the rule says if you can make the bases the same, you can throw away the bases. Just make the exponents equals to each other. Okay? You got it? Okay. Let me know when you're done copying so I can show you more examples.
Do you hear me?
No, I didn't hear you. What did you say?
Yeah, I have questions. I kind of overwhelmed, and I feel that we're going very fast. I don't know, maybe I am overwhelmed, and I have another two
Tell me
tasks.
which section you need help with.
I am confused between log, and e. I want to clarify each one, what they represent and what the difference.
Okay, log base E, we call it ln. We don't write
If
it.
it's possible, yes, Professor, if it's possible, could you please, when you clean the board, could you please put, for example, ln and then explanation, log and then explanation, and then E and then explanation? Because I want to know what between them difference.
Okay, all right. Okay, I think I understand
Thank
what you
you.
want. Okay. Did
Thank
everybody Did everybody finish copying?
Yes.
All right. I think you probably want to know what's the difference between log a number and ln a number, right? That's what you're talking about.
And then E2.
Okay. First of all, to make you understand E, what is E? E is a number. It's about 2.718, and there's lots of numbers there. So E is just a number. It's very close to 3. But we'll leave it as E because there's millions of numbers behind the decimals. So in order to be sure, so we'll leave it as E. Okay? So if I ask you, for example, evaluate. Okay, first of all, the log, if the base is E, we don't call it log E, we call it ln. So if I tell you, for example, how much is ln 81? This means this is the same thing as log with the base 2.718 of 81, which means how many times multiply 2.718 by itself to get to 81. Since you cannot do that, so this is the same thing as this. This and this are the same, but we don't put the base when you put ln. Okay, but ln 81 you cannot do it in your head, and then you have to use the calculator. Log is different. Log, for example, what is log 32 base 2? It means how many times would you multiply 2 to get to 32? So if you use your fingers, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the answer is 5. Because when I multiply 2 by itself 5 times, I get 32. Okay? Does that help you?
So E is just equals to 2.718.
Exactly. But there's more numbers behind it. I just rounded for you. Yeah.
And log and ln, they are not like that, right?
That's
They
correct.
are not equal to any number.
Yeah. That's correct.
And could you
Is that
please,
easy?
yeah, could you please move your camera a little bit top? Yeah, thank you.
All right. Okay, so let's move more. Let's move to exponential equations. So what if I want to solve 4 to the power x, 4 to the power, I'm getting something similar to your homework here, equals 256. It's called an exponential equation, right? So what do you say we do? We don't mess with the 4 to the power 2x minus 1. I like to make this number 4 raised to a power. Now, in a minute, we're not going to be able to do that. Then we have plan B for that. So what would you do? How many times would I multiply 4 by itself to reach 256? So you go to the calculator and you raise 4 power to reach 256. Okay? For example, here we go. 4, let's say, raised to the power 4. I got 256. See? You can try 4 to the power 3. I get 64. It doesn't work. So you keep raising 4 to the power till you reach this number. Then you use rule 1 that I gave you. Since these numbers are the same, you garbage them. You throw them away. You just make the exponents equals to each other. And now it's just a simple equation. 2x 5, you divide by 2, and you get 5 over 2, and that's the answer. But remember, these are hand-picked problem, means every number on the right side, you can make it to a power. Sometimes you cannot. We will have a plan B in a minute, and that will be the answer. Are we good on this example? Okay. How we're doing so far? Are we doing good?
Yes. Yes.
Okay. All right. Let me give you, shall I erase the board now?
Yes.
All right. Now we're going to do the next ones together. Remember, we're doing exponential equations. Here's one similar to your homework. Solve 3 to the power negative 3x equals 9. We don't mess with this one, right? I got to work with the 9. What should I raise 3 to a power in order to get 9, class?
2.
Power gives me 9. Who can help me?
3. Oh, I mean 2.
2. Then what do you do to these numbers now?
Cancel.
Goodbye. They're gone. And if I divide both sides by negative 3, there goes my answer. So whenever you make the bases the same, you throw away the base and you just make the exponents equal to each other. Are we good?
Yes.
Okay, go ahead and copy it, class. Still gonna show you, I'm gonna keep trying till you guys be able to solve any exponential equations, okay? Okay, let's do the next one. Let's say I have 6 to the power negative x equals 36 to the power x plus 9. Okay? So I don't mess with the 6. All right, 36. 6 to what power gives me 36, class? Who can answer that?
2.
2.
2. Now what do I do to the 6's? Garbage them. And now you just solve this equation like you normally do. I have to distribute the 2. X times x is 2x. 2 times 9 is 18. If I need x, I have variables on both sides, right? So let me get rid of the variable on the right side. 0 equals 3x plus 18. Right? Now I need the x by itself. I get rid of the 18. Negative 18 equals x. Divide both sides by 3. And my answer is x equals negative 6. So go ahead and copy this class. And if you have any question, let me know. I just need to show you one more problem on this type. Then I'm going to give you the type where you cannot make this raised to a power. Okay? Go ahead and let me know. And as you're copying, guys, don't wait till the very end says, I don't understand any of this. Ask questions as I go on, class, please. Okay? Okay, are you all done copying it?
Yes.
Okay, now watch the next example. Next example is, we'll take care of one part of exponential equations. Okay, so watch this, class. So I have, this is, you need to write, to copy it well because you're gonna have one like that on your homework. Okay, that's an exponential equations. Of course, we don't mess with this, the one on the left side, right? Okay, I can write 27 as 3 to the power 3. 64 is 4 to the power 3. Or I can write both of them as 3 over 4 to the power 3. Why? Because 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. So I'm going to end up getting 4 over 3 to the power x equals 3 over 4 to the power 3. So I'm going to pause here for a second. Do you understand what I did to get up to this step here? Yes or no? Are we good? Now, these places are not the same. That's 4 over 3, that's 3 over 4. They're flipped. Whenever they flip, watch this, class. I like to flip 3 over 4 to make it 4 over 3. Anytime you flip a fraction, you change the sign from 3 to negative 3. So if I want to make 3 over 4, 4 over 3, the exponent becomes negative. Now the bases are the same. That means I'm ready to go, and the answer is x equals negative 3. And with this one, we're done with one big part of exponential equations. Now we're going to go to the part where we cannot make the right side raised to a power.
Is that a y or 4? Like, what the y over?
This is 4.
Okay.
So the bases are not the same, but if I flip them, they'll be the same. One of the rules of algebra that if you flip this, you better change the sign of the what? Of the exponent. And that will be the answer. Okay? All right. So be sure to copy this one because I put one like this intentionally on your homework for you to refresh your memory about rules of algebra that you learned previously.
Yeah. Go ahead. Well, all right.
Okay, can I erase it now?
Yes.
Now we're going to go to rule 2 of exponential equations. What if I cannot make the right side 2 to the power? For example, solve. 2 to the power x equals 7. Can I write 7 as 2 to the power? No. So let's say x is 1. 2 to the power 1 is 2, is not 7. Let's say x is 2. 2 squared is 4, not 7. Let's say x is 3. 2 to 3 is 8. It's not 7. So there's no way in the world you can get the answer. So you know what the answer is between 2 and 3. Since I cannot write 7 as 2 to the power, right? Then the rule 2 tells me what? You place ln in front of each term. Remember ln that has the base e? Do you do this whenever what? You cannot write the right term as 2 to a power. Now, the question is solved for x. Do you remember one of the properties of logs? What's the properties of logs? I can bring the exponent to the front. Now, how do I get x by itself? I got to get to ln2, so I divide both sides by ln2. There goes my answer. Now, your book likes an answer like this, but I really don't like it. Why? I really need to know the decimal answer for this. So I'm going to go to my calculator, find ln7 and ln2, and divide them by each other. So let's do that here to make you understand what we're doing here. So this is about ln. ln7 means what? The base is 2.718. How many times would I multiply this one to get 7? See, you cannot do that in your head. That's why you need a calculator. What does ln2 mean? There's no base. The base is this one. How many times would I multiply this by itself to get 2? But you can't. That's why you have to use a calculator. So I'm going to do ln7 divided by ln2. Let's see here. Here's a calculator. 7 ln x divided by 2 ln x equals. I got 2.807. Well, let's see if I'm right. Remember, actually, there's millions of numbers behind it. So that means there's no way in the world I'm going to get the exact answer. I want to check my work. I want to replace x with 2.807. If I get close to 7, that means my answer is right. So I'm going to go to my calculator. 2 raised to the power 2.807. I got 6.99999, which is close to 7. I like it. That means my answer is pretty good because remember, I did not put the whole answers there. Okay? I really prefer you guys give me the answer in decimal, unlike your book, because I really want you to understand what the answer means. Okay? So when do we use ln in front of each term? Whenever you cannot rewrite the right term as something raised to a power, then you have no choice but use this trick. And it's legal. Why? Because it's an equation. If I take ln on one side, I took ln on the other side. Okay? All right. Go ahead and copy it, class, and I will show you more examples in a minute. Okay, how are we doing so far, class? Okay, how are we doing so far, class? Are we doing good?
Yes.
Okay, let's try another one. Let's say I'm going to solve 3 to the power equals 11. Can I write 11 as 3 to a power? It's impossible. So what I do, that's when I put ln in front of each one. One of the properties of logs, I bring the exponent to the front. And of course, to get x by itself, you're going to divide both sides by ln3. And there goes my answer. And if you want to do the decimal answer, you guys know how to go to the calculator and get the answer. I got to show you 2 more examples, class, after this. Make them a little bit harder. Are we doing good so far?
Yes.
All right. Go ahead and copy this as well. Well, I can do one over here if you guys. Let's say I want to do 4 to the x minus 7 equals 89. There is no way in the world I can write 89 as 4 to a power. 4 squared is 16, 4 to the third is 64, right? And so forth. I can never write 89 as 4 to the power, so I can make the exponent the same. So what I do, I place ln in front of each term. Let me put a divider here so you know this is a different question. So what are the rules of logs? I can bring the exponent to the front. Now, don't distribute, class. I'm going to teach you a trick here. Distributing is going to make you really mess up the problem. My advice to you is get the parenthesis by itself. Divide both sides by ln4 first. So you're going to get x minus 7 equals ln 89 divided by ln4. That's much better than distributing. To get x by itself, I need to move the minus 7 to the other side. It becomes plus 7. And now I'm done. So if I want to get the answer to this as a decimal, I'll find L89, I divide by ln4, and then I add 7 to it. So if I go to my calculator, if I want to get the decimal, just in case you guys want to know what we're talking about. So 89 log, ln I mean, divided by 4ln. Then I'm going to add 7 to that. So the decimal part is 10.238. So I can check my work. If I replace x with 10.238, 10.238 minus 7 gives me what? 3.238. And I bet if you raise 4 to the power 2 what? 3.238, you're going to get close to 89, maybe 88 point something because we rounded. Okay? So this is important to learn my trick. Don't distribute here to get x. Divide by ln4 on both sides. That would be much easier than distributing, class. Okay? All right. Go ahead and copy it and let me know if you have any question. I just need to show you one more example and we'll be done with the chapter. Okay. All right, last example of the day. So be sure you guys have the rules in front of you when you do your homework assignment. Okay, that's gonna help you a lot. Have the notes in front of you so that way you don't. So here we go. E to the power x equals 31. And this is for the young lady who doesn't know what, got confused about E. Okay, this means 2.718 whatever to the power x equals 31. This means how many times do I need to multiply 2.718 by itself to reach 31? Let's say this is 3. 3 times 3 is 9, times 3 is 27. Oh, so it's 3 something, because 27 is close to 31. So my answer should be a little more than 3. But I cannot try 31 e to the power. So what I do, I place ln in front of each term. Now I use the of the rules of exponents for ln. I bring the exponent to the front. Do you guys know how much ln e is? What's the base of ln e? E. E to what power gives me e? E to the power 1. So this is 1. X times 1 is x. That will be my answer. Remember, ln e. There's no base. The base is e. E to what power gives me e? E to the power 1. ln e is 1. So ln 31. And with this, I covered every single thing you need to know about exponential equations or logarithmic equations. But it's so much to digest. That's why be sure you guys have all the notes in front of you before you do the homework. Okay? All right, you can copy it. If you guys have any question, you let me know. Okay? Okay, once you copy all of this class, you're done. And I already videotaped this. Here, I'm going to stop recording here so you guys can see the videos at your leisure. Okay? So with this, you should guys